All right, this problem is a little longer, and number 5 has a binomial. It looks like it's already in factored form, a monomial times a binomial, and then I have the equals 21. This would have been fine if it was in factored form if I had it equal 0, but I don't have an equal 0, so that means that I'm going to have to distribute my x. So I'm going to have x times x is x squared. X times negative 4 is negative 4x. And bring down my equals 21. Now I need to get an equal 0 before I can begin my factoring. So I need to subtract 21 to both sides. So I have x squared minus 4x, and I'm going to squeeze that negative 21 in after the negative 4x. Okay, and then bring down my equal 0. Now I have 3 terms, 1, 2, 3. So that means perfect square trinomial, GCF, or the bottoms up is the only thing I can do. There's not a GCF. I can't take the square root of 21, so I have to do bottoms up. So I'm going to multiply the first and the last, and I want to find the factors of 21, because 1 times 21 is 21, that subtract to give me a negative 4. Okay, so I have 1 and 21, 3 and 7. 1 and 21 is not going to work, but 3 and 7, I can subtract 3 and 7 to get 4. Now remember, when you're subtracting, you need different signs, and the bigger number needs to be the sign of that middle term, so I need a negative 7 and a positive 3. I divide by that leading term, x, and so when I do my bottoms up, I have x plus 3. When I do my bottoms up, I have x minus 7. So now it's in factored form. I'm going to set each factor equal to 0. So x plus 3 equals 0. X minus 7 equals 0. When I subtract 3 to both sides, I have x equals negative 3. When I add 7 to both sides, I have x equals 7. So I have negative 3 comma 7. That's my answer. Now let's go to our next page. And our next page has, our first example is really nice. So I'm going to bring that down in case you needed to look at it a little further. Alright, so our first example is in factored form, and I see it equals 0. Remember, if you have equals 0, the next step you do is factor it. Well, this is already in factored form, so this means that this is the best problem we've had so far. I'm going to go ahead and set my factors equal to 0. I don't have to factor it because it's already factored for me. And so when I factor it, I'm going to set each factor, once I set each factor equal to 0, I'm going to solve. So I'm going to subtract 5 to both sides for the first one. So x equals negative 5. And then I'm going to subtract 3 to both sides for the second one, and I have 2x equals negative 3. I got to do 2 steps on this one. I need to divide by a 2, and x equals negative 3/2. So my answer is negative 5, negative 3/2. All right, so that one was a little more complex, but it's not at the same time. It was really easy, but we had to do 2 steps in our solving, so it made it a little harder, but it wasn't. All right, number 7. I have y to the third plus 14y to the second plus 49y equals 0. I have my equals 0, so I don't have to move anything over. I have 3 terms, and I have a y cubed. So this is telling me I have a GCF of a y, because y to the first is the smallest exponent. And when I take out a y, I'm left with y squared. If I take out a y from the second one, I'm only left with y. If I take out a y with my third, I'm just left with 49. Okay? Now, I have 3 terms. I'm going to go ahead and bring this down into my answer, so I won't look at that y on the outside. I have 3 terms. With 3 terms, remember, you can do GCF, which we already did. You can do bottoms up, or you can do perfect square trinomial. Can I do a perfect square trinomial with this one? Can I take the square root of y squared? Yes. Can I take the square root of 49? Yes. Is this a plus? Yes. So let's look and see if we can do a perfect square trinomial. And I'm going to erase one of these parentheses so we can do it. The square root of y squared is y. The square root of 49 is 7. The middle term is a plus, so I bring down a plus, and I put it in parentheses squared. Now, what does that mean when I have y plus 7 squared? That's the same thing as y plus 7 times y plus 7, correct? All right. Now, the reason why I rewrote it like this is because, remember, we're going to set each factor equal to 0. You can set this equal to 0 and not worry about the exponent, or you can write it out like this. Now, why does it matter, or why doesn't it matter if I write it this way or this way? Because let's watch. If I set this first factor equal to 0, y equals 0 is already solved. If I set this factor equal to 0 and this factor equal to 0, what's going to happen? Well, when I subtract 7 to both sides, I'm going to have y equals negative 7. What happens when you subtract 7 to both sides here? You're going to get the same thing. There's no point to do this twice. It makes no sense to write the same answer 2 times. So for your answer, you're going to have 0 and negative 7. Don't write it 2 times. That's silly. Okay? So you don't have to rewrite this as an exponent in an expanded form. You can just write it 1 time and set that factor equal to 0. You don't have to worry about the exponent at all. Or you can expand it and just write it 1 time. If it's the same thing, don't write it more than once. It will be the same answer both times. Okay? So this one had a GCF and a perfect square trinomial, and it ended up being a pretty easy problem. Let me pick up on number 8 in the next video.